here we're going to do the inverse. We're going to do cotangent today, graphing those. And we'll start with just graphing the cotan curve. We're going to do the inverse. So this is f of x is equal to cotan x. And we know that we can graph this between 0 and pi. Those are if we were doing the bookends. And that's just one period of it. We could there's an infinite number of periods. There's asymptotes here as well. And then I'm going to just do one for negative pi as well. Okay. But we're going to restrict that domain for the inverse function so that we have just one answer if I ask you about cotan. And so the domain for the cotan function is all real numbers, and from negative to positive infinity, except for all the x's that cannot equal pi. 0 plus or minus. In any number types of 1 pi, 2 pi, 0 pi, negative pi, whatever pi. So, and then the range is all real numbers. It goes from negative and positive infinity. So a good domain restriction is the one that we're most used to using, and that's between 0 and pi. And so our inverse function for cotan will be have a domain from negative to positive infinity, and the range will be restricted to what we are really used to from 0 to pi. We're going to skip all of this for now, and then just fill in these things, and we'll start with the cotan. Angle whose cotan is 0, and that will be pi over 2. I just erased it, I'm not sure why. Okay, the angle whose cotan is square root of 3 over 3 is that's your famous 60-degree angle, because it's the reciprocal, remember, of tan. So it's the pi over 3. And the angle whose cotan is 1 is our friend pi over 4. And all of these are in quadrant 1. This is a quadrantal angle. Not in a quadrant at all. Angle whose cotan is square root of 3 is pi over 6. Again, it's in quadrant 1, just like the other ones were as well. And now let's do the negative angles. The angle whose cotan is negative square root of 3 over 3 is 2 pi over 3, because we're only going to be using between 0 and pi. So that's just like cosine. We're going to use quadrant 1 for the positive cotan angles, and quadrant 2 for the negative cotan angles, just like cosine. Okay, so we're not going to use anything in these quadrants at all, Q3 and quadrant 3 and quadrant 4. The cotan doesn't exist in quadrants 3 and 4 because of the restrictions that we placed on cotan x, the y equals cotan, to make it a function that is 1 to 1. So that basically, so that we get only one answer for every x. There's one y. For every y, there's one x. And again, this is very similar to cosine, inverse cosine of x. Okay, finishing this up. So that's why it's 2 pi over 3 rather than a negative pi over 3. We're actually finding 2 pi over 3 in this quadrant, just like we did for cosine. So cosine and cotan use quadrants 1 and 2. Tan and sine use quadrants 1 and 4. So this is in quadrant 2. The angle whose cotan is negative 1 is it's negative, so it's in quadrant 2. And the reference angle is pi over 4. So in quadrant 2, that'll be 3 pi over 4, just like it would be for cosine. And for angle whose cotan is negative square root of 3 has a reference angle of pi over 6. In quadrant 2 will be 5 pi over 6. So there's not going to be any negative answers here, just like it is in cosine. Okay, now we're going to work some problems, and let me find them for you. And let's see, I'm trying to get a clean copy here so we can start fresh. And okay, so the angle whose tan is pi over 4 is in quadrant 1. It is pi over 4 in quadrant 1. In quadrant 2, the angle whose cotan's negative square root of 3 is 5 pi over 6. And again, that's in quadrant 2. Cotan, we just did this. Angle whose cotan is negative 1 is arc cotan. Negative 1 is 3 pi over 4. Again in quadrant 2. And then the angle whose tan is square root of 3 over 3 is in quadrant 1, and that is pi over 6. That's the tan, not the cotan, so be careful. Not everything's cotan. So the angle whose cotan 0 is pi over 2. And again, it's a quadrantal angle. It's not in a quadrant. Angle whose angle whose tan is negative square root of 3 is in quadrant 4. It's not cotan, it's arctan, just that angle whose tangent is negative square root of 3, so it'll be negative pi over 3 because the reference angle is pi over 3. Okay, so the arctan of the tan, now we come down here of 5 pi over 3. Again, we always going to do this, we're going to do this first. Remember, this is an angle, so we want to find the angle whose tangent is the tan of 5 pi over 3. So we have to figure out the tan, this part first. What is the tan of 5 pi over 3? So we say, okay, the arctan of the angle, the tangent that has tangent 5 pi over 3, the tangent of 5 pi over 3 is negative square root of 3. Okay, so that angle is negative pi over 3. Okay, so the arctan of the tan of x is going to be equal to, this will help you with some of the problems that you have seen on some of your worksheets. The arctan of the tan of any angle x is equal to x if x is between negative pi over 2 and pi over 2. So just a quick note on that. Okay, angle whose cotan is the cotan of 7 pi over 6. Okay, we have to find what that cotan is going to be, so that we need the angle whose cotan is the same as that for 7 pi over 6, which is square root of 3. And that is pi over 6. Okay. And doing number 3, the tan, you have to find that angle. Angle whose sine is, that's pi over 4. I hope you recognize that. And that's equal to 1. Cosine of the arc cotan, the angle whose cotan is 1, it's the same as angle whose tan is 1. So that's the cosine of pi over 4. And that's the square root of 2 over 2. Okay, so moving along, we'll have, you can find all the answers on Blackboard, but let's just do a few of these. I'd like to do number 8. Looks like a tricky one. Well, actually, number 7. Number 7 is really tricky. The angle whose tan is the tan, so the arctan of the tan of pi over 2. The angle whose tan is the tan of pi over 2. So basically, this is the angle whose tangent is undefined. That basically, if tangent is undefined, it's not defined. DNE does not exist. Okay, let's go on to 8, and I think then we'll maybe do number 10. So the angle whose cotan is the cotan of 4 pi over 3. So we need to calculate the cotan of 4 pi over 3. It's in quadrant 2, and so it'll be negative, I believe. It has a reference angle. 4 pi over 3 is actually in quadrant 3. So that's going to be positive. Cotan of 4 pi over 3 is square root of 3 over 3. And that's angle pi over 3 for cotan. The angle whose cotan can't be in quadrant 3. We need a quadrant 1 angle. So that's pi over 3. We can only use quadrant 1 for positive cotan. Okay, just remember that. That's tricky, tricky, tricky. Okay, let's look at some of the other ones that we'll be doing. Again, all the answers are on Blackboard in your notes section. The answer key has been posted so that you can check some more out if you want to see them. The secant of the angle whose sine is the square root of 2 over 2. That's a little tricky because we have to do the reciprocal. But this is equal to the secant of the angle whose sine is negative square root of 2 over 2. So that's an inverse function. So we have to use quadrant 4. That's what that is, because the angle's negative and the reference angle, pi over 4. So this is negative pi over 4. So we want the secant of negative pi over 4. Okay, well, secant's equal to 1 over the cosine of negative pi over 4, which is going to be 1 over the square root of 2 over 2, which is square root of 2. Okay, and then cosecant, I'll do one more of these reciprocals. We want the cosecant of the angle whose cosine is negative square root of 3 over 2, and that's going to be the cosecant of the angle whose it's in quadrant 2 because it's negative, has a reference angle. The cosine is negative square root of 3 over 2, so theta prime, the reference angle is pi over 6, and that will be 5 pi over 6. Just like it is for cotan. The cosine and cotan are only positive and negative in quadrant 2. Okay, so this is equal to the reciprocal 1 over the sine of 5 pi over 6, which is 1 over 1/2. We know that because that's in positive in quadrant 2, and that's 2. Okay, now let's do the calculator to do, you're going to use the calculator to do some of these common, of the inverse trig calculators, and inverse trig values, rather, using calculators. For common inverses, you just enter into your calculator. The mode can be either radians or it can be degrees, depending on your instruction for the problem. So for these are going to be, these are radians. When you see something like that, there's definitely radians. So the radian answer, although if you are given no instruction, then you can do either one, but to me it looks like a radian. But we're going to get both answers, so that you can see that they are definitely different. So we'll start with radians. So put it into radian mode. I'm in radian mode. I'm also in polar function mode, polar mode, and I need to be in function mode, so I'm going to do that. And so we go, the angle whose sine is 0.2. So second, go second. Okay, let's be quick. So second sine, 0.2 in radian mode. And so we get theta is equal to 0.201. I'm going to go ahead and do the rest of them in radian mode so that I don't have to keep switching back and forth. So negative cosine, second cosine, negative 0.75. And then we'll do the degree mode. You will see that there's a very big difference. When we're rounded to 3 decimal places, 419.419, and arctan, and same as Angle whose tan is the inverse tan. Arc tan is just another way of representing that. So the second tan, 5.22, and we get 1.382. Okay, and then when you go to degrees, we're going to do the same. We're going to just change that to degrees. Enter. And you can go second enter, second enter, second enter. And that gives us, now it's in degree mode, it's going to give us a different answer. So it's 11.537. I think you know that if you go second enter, it brings up the command that you had just put in. So I did that a couple of times because I wanted to go up a couple of lines. I'm going to push second enter. I don't want that one again. I want tan of 5.22. No. I can do it now, so I'll go ahead and do that one. That's this last one, so it's 70, just a minute. Yeah, put that in. Angle whose tan is 5.22. And just make sure I'm in degree mode. Okay. Okay, so we get 79.155 degrees. And let's do the angle whose cosine, second cosine, is negative 0.75. And I get 138.590 degrees. Alrighty, so now let's finish these notes. So to do reciprocal inverses, we're going to set the inverse expression equal to the theta, and then you're going to rewrite it as an equivalent equation without inverses. So the angle whose secant is x is theta is written as this. So the secant of theta equals x. This is another way of writing it. And then you're going to reciprocate both sides of the equation. Reciprocate means you're going to turn both sides into reciprocals. I think maybe we invented this word. So you rewrite the reciprocal as a common trig functions of sine theta, cosine theta, tan theta, and then you solve for theta using the inverse expression. So here we're going to do that. So here's a function, and we're going to be in radian mode. So go back to your calculator. Change to radian mode. And so we want the angle whose secant theta is equal to, so it's the second 1 over cosine, 6.93 is what it says. And so the cosine will equal, because it's the same angle, it's just that we just are representing it in a different way, 1 over 6.93. So we basically will say that theta is equal to the angle whose cosine is 1 over 6.93. That's the idea here. And so then we'll say that theta is equal to, let's find out. So make sure that you're in radian mode and go to second cosine. And we get 1 divided by 6.93. And we get 1.426 radians. So that's theta. We could do that again for cosecant, and we will. So cosecant of theta, we rewrite this. The cosecant of theta is equal to negative 1.5, which means that the sine of theta will equal 1 over that. So negative 1 over 1.5. And then writing that as an inverse. So we write theta is equal to the angle whose sine is negative 1 over 1.5. And then we go ahead and do that one as second sine, negative 1 divided by 1.5. And we get theta equals 0.730. And it is negative. Okay. So let me just do something real fast. 1 divided by 1.5. Okay, insert. I'm just going to do that real fast. Okay. Now we're going to do a few more of these in cotan. So we're going to rewrite this. The cotan of theta is, okay, we're trying to refocus here. For some reason it's deciding to refocus. Cotan is equal to 6.5. And then the tan of theta will equal 1 over 6.5, and theta will equal the angle whose tangent is 1 divided by 6.5. Okay. We're going to just do that, so that put parentheses around that. And we get second tan of 1 divided by 6.5. And you get 0.153. So theta equals 0.153. Okay, I will leave the rest of these for you to try on your own, and you could check your answers on Blackboard. Sometimes we have troubles because the calculator is not as smart. It's not as smart as you are. Remember that tangent is only defined, inverse tangent is only defined in quadrants 1 and 4. And so if you've got a negative angle and you find the inverse tangent of that angle, for that angle, then it's going to give you an angle in quadrant 4. But cotan is not defined in quadrant 4, the inverse. So we will have to adjust what we get from the calculator, because the calculator only knows about this pattern for tan. So we're going to rewrite the inverse of a negative, and that only happens with negative values. As we're going to rewrite it as the inverse tan, and when you do that, it will not give you the right answer, because it gives you an answer in quadrant 4. When, if it's negative, cotan is only negative here in quadrant 2, not quadrant 4. But tan's negative in quadrant 4, so it's tricky. So the reason that we're just formalizing that is that inverse cotan is negative in the second quadrant, and inverse tan is negative in the fourth quadrant. So because of this, you have to adjust your answer. So if you get a negative, if you have a negative cotan, then you have to change what you get from the inverse tan, and that adjustment, all you have to do is just add pi, because if you add pi, or 180 degrees, what will happen is you get something in the second quadrant. So that's what we're going to do. Here we have an example of that. The tangent, cotangent is negative 3.41. That means it should be in quadrant 2, but your calculator is going to give you something in quadrant 1. So this is equal to theta. And the cotan of theta is equal to negative 3.41 when we rewrite that. Okay, so that means that the tan should equal 1 over that. So 1 over negative 3.41. And so theta should equal the angle whose tangent is negative 1 over 3.41, but that will give us a second quadrant angle. So we have to add pi to that. And when you do, then no problem, you'll get the proper answer. So theta will equal, I'm going to put this in the second tan, of negative 1 divided by 3.41. I'm just going to show you what you get there. So you get a negative 0.285. That's less than 1 radian. That is actually right there in quadrant 2. That is not where cotan is defined at all for negatives. So we have to add pi to that. So we're going to add pi. And to get the proper answer, which is 2.856. So this becomes theta will equal negative, I'm just rewriting the numbers we got up here, negative 0.2853, and we have to add pi to that, and so we get 2.856. That is, if you think about it, that's in quadrant 2, because this is 3.14 radians, which is pi, and that's not too far away from that. Okay? So here's another one, and then I want you to try a couple of them. So we'll do one more. So the cotan of this angle of theta, this is theta, is equal to negative 5.6. That's the idea. And so that means the tan of theta is equal to negative 1 over 5.6. The lights just went out again, so we have to turn them back on. I bang my foot on the floor and it turns them on. Theta is equal to the angle whose tangent is negative 1 over 5.6 plus pi. That's all you have to do. So this only is a problem when cotan is negative. Okay, and then we get the answer. We're going to type that in. The second tan negative 1 divided by 5.6. And we're going to add pi to that, plus pi. And we get the correct answer, which is theta equals 2.9665. 96.965. Okay, I'd like you to try those last two to see if you get the correct answer. And I'll put the answer on here. The correct answer is 3 point. You try them. Okay, so now we're going on to the next section, and that will be section 5.1, day 3. Okay, and so we will cover those. We'll cover part of that right now. So we're on page 11. When some inverses are not common values, and so when this happens, you have to draw a triangle, just like you did when you were doing this earlier with some of your problems. You even had them on your test. So we have to draw a reference triangle, but you're going to make an equation that has an inner function, set it equal to theta, and then you're going to draw a reference triangle. It's just a triangle with, and you know that the angles whose sine are x, they're in quadrants 1 and 4, and cosine is in 1 and 2, tan's 1 and 4, and cotan is 1 and 2. So that's going to make it. So these two are the same. These two are the same. 1 and 3, 2 and 4. Okay. Find the missing side using the Pythagorean theorem. These are just the steps. And then state the ratio of the outer function using the reference triangle. Okay, so here's how it works. We want to find the tan of this angle. So this is an angle, theta. Theta is equal to the angle whose cosine is 1/3. So we're going to draw a triangle. It's positive. It's the angle whose cosine, so it's going to be in quadrant 1. Only one answer here. And the cosine of this angle, theta, is 1/3. So it's 1/3 hypotenuse, which means that the third side is going to be the square root of 8, which is equal to 2 times the square root of 2. So what's the tan of that angle? So the tan of theta from here is opposite over adjacent. So it's 2 times the square root of 2 over 1. So it's just 2 times the square root of 2. Okay, so that's not too bad. Okay, and then we're going to find the cosine of the angle whose sine is negative square root of 2 over 3. Going to do the same thing. So this is theta. This is an angle that's theta. So we want to find the angle whose sine is theta. The sine, excuse me, yeah, the angle whose sine is negative square root of 2, just like it says, over 3. That's our theta. And so basically what we're finding is, so we say the sine of the angle theta is equal to negative square root of 2 over 3. And what quadrant's it in? If it's negative, it's going to be in quadrant 4. Okay, so here's theta. And the sine of theta is negative square root of 2 over 3. So that this is negative 2 square root of 2. This is 3. Negative, this point, this is always going to be negative. Hypotenuse is always positive. And so now we have to find that third side, which when you use Pythagorean theorem, I'll let you do that on your own, is the square root of 7. So the cosine, which is what we're looking for, of theta, that's what we're looking for, is equal to square root of 7 over 3. Okay. Now, a little trickier. We're going to do reciprocal functions. And the cosecant of the angle whose tan is negative 2. So the angle whose tan is negative 2 is equal to theta. And the tan of theta, this is theta again, remember. This angle whose tan is right here, that's theta. So the tan of theta, rewriting this, is going to equal negative 2. We can write it as negative 2 over 1, and it's in quadrant 4. Okay, so we have a triangle, and we're going to draw it in quadrant 4. Okay. And theta is right here. Tan is negative 2 over 1. The 1 is going to be positive. That's the adjacent side. It's 1 because it's in tan. This side is 1. This is negative 2. And then the hypotenuse will be square root of 5. I'll let you calculate that on your own. The sine is negative 2 over the square root of 5. But the cosecant, which is what we're looking for, cosecant of theta, will equal the hypotenuse over the opposite, which is negative 2. So I'll put that negative right there. And there it is. Okay, I'll let you try that last one. You try it. And come back to this in just a moment. Turn your video off and then come back. Okay, did you get negative square root of 2 over 2? Great. Okay, let's look at what your homework is going to be for this. I guess it's over the break. No, I'll see you. I won't see you until after the holidays. So have a great, wonderful holiday. Your homework will just be a regular homework assignment. I'd like you to do, let's see, worksheet number 2, you have to finish up the cotan. So finish worksheet 2. You didn't do all of it last time, so you have to kind of finish that now. And then let's see. It started on worksheet number 3, which will be, let's see, on page, so you're going to finish worksheet 3 on page, this is worksheet 2 goes through page 7, and page 6 rather. So worksheet 3. So you finish worksheet number 2, and then you're also going to do worksheet number 3. You won't do them all, but you're going to do 1 through 8. I think actually 1 through 4. That's it. We'll finish that over after the holidays. Okay, so homework. This is your homework for tonight. Do it tonight so that you don't have any homework over the break. Do it today. Okay, have a great holiday. Bye.